When choosing your object detection model, so the architecture for your object detection task, you also need to consider how the resolution of the images affects your object detection model. So by the resolution, we mean the width and the height of the image. And in the paper that was referenced, we see this graph here where they have made some experiments and they have shown us the results here. And as we can see, the blue color represents images or models that was trained on images with resolution 300 by 300. And the green color represents models that were trained on images with size 600 by 600. And again, the circle represents FastRCNN, the square represents RFCN, and the rounded square represents SSD here. So from here, we can see some immediate things. For example, if we choose, or if we have large images, so 600 by 600 in our input, we see that overall FastRCNN performs better. So the accuracy or the mean average precision is much better when using FastRCNN. And here we see that on the lower end, when we choose, for example, SSD here, and with 300 by 300 images, we see that we can get some good mean average precisions and very good speed here in terms of prediction. So this is something that you should also consider. And I actually have faced this myself when I was working in the industry. So at some point we were resizing our images in order to fit them to the neural network that had 600 by 600 as inputs, for example. But I realized that if we can somehow look or just choose a region in our image and just crop that region 600 by 600, then we would get much better results, because then the object will not look very small, because it will look small if we resize a large image and we make it only 600 by 600. So we made some decisions based on what we know about how the model performs in terms of the image resolution that was used when it was trained. So this is something that you should consider. Always remember that when you choose a specific image size or image resolution for your model, this means that whenever you have to pass new images through the model, you actually have to resize them to that specific resolution. And if you have small objects in your image and your image is large, then what happens is that when you resize it and you make it smaller, the object will look very small. And when the object looks very small, then it might be harder for the neural network to detect. So in this specific case, you need to figure this out. For us, for example, as I have mentioned, what we did was we used some a priori information that we had from some sensors, and we were able to tell at least where the model exists with some relative precision. Of course, it wasn't a good precision, otherwise we wouldn't have used object detection with deep learning in the first place, but we had some sort of an information that tells us that in this specific region, for example, the object exists. So what we did was just crop our image 600 by 600 and then pass this crop here through the network instead of resizing all of our large image. And these are very important points to consider when choosing your object detection architecture.